Hello everyone. In this video, we are going to learn how to determine the numerical aperture of an optical fiber. Before going to the experiment, we will recall some of the basics. When light travels from one medium to another, what happens? The frequency remains constant, whereas wavelength and velocity changes. These changes cause a bending of light when it goes from one medium to another medium. Now, we will take an example. We have two medium 1 and medium 2. Medium 1 is a rarer medium 2 is a denser medium. When light incident from medium 1 to medium 2, it will bend towards the norm. Whereas, if the light incident from denser medium to rarer medium, it will bend away from the norm. This bending of light is known as refraction. Now, if we take the case for light going from denser to rarer medium, this angle is known as angle of incidence and this angle is angle of refraction. Now, if we increase the angle of incidence, angle of refraction also increase. Then, at a particular angle of incidence, angle of refraction will be 90 degree. This angle is known as critical angle. If we incident a light whose angle of incidence is greater than critical angle, the ray will bend to the same medium. This is known as total internal reflection. Optical fiber utilizes total internal reflection to guide light. The structure of an optical fiber consists of two solid concentric cylinders. The inner cylinder is known as core and the outer cylinder is known as cladding. The refractive index of core is greater than refractive index of cladding. Here, we can see a schematic diagram of cross-section view of optical fiber. Now, if we incident a light at the core cladding interface, when angle I is greater than critical angle, then total internal reflection will take place. When light incident on an optical fiber, it travels from air medium to core medium. Due to the difference in refractive index, refraction will take place. The refracted ray will be the incident ray at the core cladding interface. And if angle I2 is greater than critical angle, total internal refraction will take place. From this, we can see that angle I2 depends on angle I1. The maximum value of I1 is Imax. If we take a 3D view of Imax, we get a cone. This cone is known as acceptance cone. Imax can be calculated by this relation and sign of Imax is known as numerical aperture. The aim of this experiment is to determine the numerical aperture of an optical fiber. The apparatus required are laser source, photodetector, and optical fiber. This is the picture of our experimental setup. We have laser source, optical fiber, digital voltmeter, and a photodetector. The laser source, photodetector, and digital microvoltmeter can be on by using the switches. This is the laser source, which is 660 nanometer in wavelength. And laser is passing through this optical fiber and will reach this end. And the output of laser light is measuring using the photodetector. And the photodetector is connected to digital microvoltmeter, which have ranges microvolt, millivolt, and volt. Now, in the next 2 videos, we will show how to perform the experiment. The distance between the output of optical fiber and the photodetector is denoted by L, and the corresponding intensity can be seen in the form of voltage. The alignment between these two can be changed by using the screw gauge. We can see that there is a change in the voltage as we change the alignment. This alignment is measured in terms of D. Now, we will explain how to measure distance D. This is a schematic diagram showing the intensity profile of laser light coming out of optical fiber. Distance D is the lateral displacement of the photodetector. Now, we will show a video of how to measure the distance D. The photodetector is attached with a screw gauge. The lateral displacement can be measured by this screw gauge. Observation. For a fixed L, we will measure the intensity at different D. Then, we will plot the intensity profile. From this intensity profile, we will measure width by taking 5% of the maximum height. Then, we will repeat this for different L and calculate the numerical aperture using this formula. Here are some precautionary measures that has to be followed during the experiment. The laser light coming out of optical fibers should fall properly on the input of photodetector. Handle optical fiber gently. Do not directly look into the laser light. Minimize room intensity near the apparatus because this will influence response of the photodetector. Avoid fluctuations of room light intensity near the photodetector during the experiment. Do not change the voltage scale of photodetector during the experiment. Thank you.